Hello, this is Dr. Thompson from Taylor University, and I'm going to be giving you an introduction to integration by parts. This is an integration technique you learn in Calculus 2, and this is basically doing the product rule for derivatives backwards because there is no product rule or quotient rule or chain rule for integration. So it's a bit harder to do integrals, but we can try to kind of anticipate and do those things backwards. So the product rule was for products for derivatives. So when we see products here, we're going to try this technique that's inspired by the product rule. And so here, my original problem is the integral of x times e to the x dx. So I do have a product in my integrand, and I'm going to use this formula here at the bottom. This is the formula for integration by parts. And the idea is that I pick of what I have in my original integrand, including the differential, I pick part of it to be something I'm going to call u, and I pick another part to be called dv, which is the thing I'm going to integrate. U is the thing I'm going to differentiate. On this right side, u and v are just multiplied, but then I have a new integral where dv has been integrated to v, so right here, and then u has been differentiated to du. And so the two things you pick are going to switch places. One is going to be integrated, one is going to be differentiated. So you want to differentiate the thing that is easy to look at when it's after it's differentiated, that becomes simpler. And then the thing that you integrate is probably going to get more complicated, but you want it to minimize that. You really want to focus on, let's do something that is easier when you differentiate. That's usually the key. So let's go ahead and look at what we're going to pick for this problem. Now when you look at this problem, x here is probably the simpler thing because e to the x, whether you differentiate or integrate, you get e to the x. However, x, when you integrate, you get x squared over 2, which is kind of unhelpful. But if you differentiate, it becomes 1, and that's very nice and easy. So I think that's going to be my choice of u. So we're going to pick x here to be u, most likely. So we'll pick him to be u. All right, so let's take a look. So on this step, you can see that I've picked u to be x, and of course I'm going to need du. So just like in w substitution, I already split the differential, so du equals dx, or 1 times dx. And then dv is the rest of it, including the dx. So dv equals e to the x dx. And there should be a differential on both sides because I'm going to integrate both sides. And when I do that, I get v equals e to the x here. There's a plus c, I guess, but we're just going to put the plus c at the end of the entire problem. So don't worry about that at this step. So we've got our 4 pieces that we need for our formula, and so I'm going to take the original here and I'm going to replace it with the right side of the formula here because those things are equal. And so let's look at that on the next slide. All right, so you can see here in the center, I have replaced the original problem with the right side of this formula. U was x, v was e to the x, so that's where I got the first part. And then I subtract the integral of v du. Well, v is e to the x, and du is just dx. So the actual part I have to integrate, which is only the second part here. I don't integrate the first part. It's done. I just need to integrate e to the x. And so that integral, like we already know from above, is e to the x. So let's do that on the next slide. Let's finish our new version of the problem. All right, so I've integrated. So now the problem has become, well, it's done, right? It's become x e to the x minus, that integral became e to the x plus c. You could think about distributing the negative for the plus c, but because c is an arbitrary constant, that doesn't matter. It's whatever you want it to be. So we can just put a plus c there. All right, so in the middle here, I've kind of just changed the problem to a new version, and you can't see all that together. So let's do one slide where we show all the work. Okay, so this is how the work might look on your paper if you're turning in homework. Here's the original problem. Here are my choices for u and dv right here. That's setting up integration by parts. I did not write the actual integration by parts formula on here, but it might be a good idea as you're doing the homework just to memorize it because you will need it memorized. And then here's the original integrand. Here's what it becomes through integration by parts. And then here's the resolution of that new version of the problem, including taking the antiderivative of e to the x. And this final answer right here, you can differentiate it, and of course you will use the product rule when you do that, and you will get back the integrand for sure. So you should check that as well. All right, so that is our introduction to integration by parts.